Hello, everyone. I'm Elisa from IPAN, Mexico. Welcome to the last day of Blockchain Z Days. Today, I have the pleasure to introduce the amazing speakers of the talk, Demystifying NFTs, creating an NFT smart contract on near blockchain. Before giving the word to them, I would like to remind you at the end of the session, we will have a Q&A session. So I encourage you to write your comments and questions in the right side of the page. So having mentioned this, please giving warmest welcome to Sahar Kirlov and Luis Mastrangelo. You have the microphone, guys.
Hello, hello, dear friends, and welcome to our talk today that will be delivered by myself, Zahar Kirillov. I'm a project manager at EPAM Switzerland, and I'm with the blockchain domain somehow connected within the almost past 10 years. And during the last year, I'm working with EPAM Blockchain Development Center. And here we will present you a short summary of our recent developments on the NFT topic. And as it got quite a huge hype during the past half a year, we decided to summarize our experience and share it with you. And today with me will be our fellow colleague Luis. Please introduce yourself.
Yeah. Hello, everyone. I'm Luis. I'm here at IPAM since like a year now, and I've been getting in the last few months working with blockchain. I'm learning a lot, and I hope I can share my experience working with Sahar and our team, working with NIR on NFTs.
Thank you, Luis. Thank you. So we structured our talk into two sections, and we start from a little bit theoretical part that will be covered by me, and in the second half of our presentation, Luis takes over and shows you the demystification of the smart contracts and the code. So if I made to set a goal of our talk and our discussion here, so why we're here, is just to bring you the message that NFT is not a spacecraft, and it's not something very difficult, and that every business person and every developer can master, and it's sometimes worth mastering, and we will discuss the situations and the use cases where the NFTs are in use and how to make best out of it. So that's our goal. So I will cover those topics. First of all, we will do a short recap of what are NFTs designed to be, so how they are scheduled to operate. Then we will summarize what are the known pitfalls at the current state. So if someone will be watching this video in 1 to 3 years, probably those hopefully will be solved by that time. But as of today, we will mention few, and then we will dig a little bit into the development, and then the microphone goes to you, dear listeners and watchers, for the Q&A session. So let's start diving in. Just to set the baseline where we are and why we are naming something non-fungible tokens, or in a more generic sense, non-fungible assets. So if we say non-fungible assets, there should be fungible assets as well, apparently, right? And fungible assets, basically, all the fiat money, all the paper money that we hold in our wallets, all the bitcoins, all other cryptocurrencies, the gold, precious metals, stock shares, everything is fungible. Why is fungible? Because if I have a $1 bill in my pocket and Luis has another dollar bill in my pocket, we can easily swap them around, and none of us becomes richer or poorer. So they are, even if my dollar bill here on the left-hand side looks like a not very nice and new, it has exactly the same value and exactly the same purchasing power as the brand new dollar bill, just fresh printed, as you can see on the right. So that's what fungible assets look like and what is their meaning. So, but apparently, next to the fungible assets, there are a different class of the assets called non-fungible. And to illustrate it, let's take an example of the flight tickets. So we hopefully we can soon fly again frequently as needed. But yeah, if someone forgot how the flight tickets and boarding passes look like, so here is a picture, and you see that basically the whole flight departs at the same time, and the whole flight lands at the same time, and all the people in the aircraft they travel to the same destination, but many people in the aircraft paid different prices for the ticket. So they have all the same tickets, but the price of the ticket and the value of the ticket for each passenger really depends on many factors. And for example, one prefers the aisle seat, and another one the window seat. Someone prefers the business class, and others travel in the economy class. Someone purchases a ticket in the last minute, and others purchase them kind of well in advance. And all those factors actually matter, and they impact the price. So when you see two people on the same aircraft, they might have their tickets that were priced differently, and probably not every person will exchange his or her ticket to another one, because the ticket has some value that ultimately has a value for this particular person, for this particular day, and for this particular flight. So two tickets are not interchangeable, and yeah, probably if you would like to interchange them, then you need to pay extra, or you ask something additionally when you're changing the ticket. So that's an essence of the non-fungible assets or non-fungible tokens. So basically the same is in the blockchain. And if we would like to get some sort of the definition of the non-fungible assets applied to the blockchain, then actually, as you can probably be facing any other definitions that are around in the world. But we would like to make a statement that it's nothing else than just a blockchain record that certifies that some set of the data attributes at a given time was stored at a given address, and obviously this address belongs to some person who owns it and who has an ultimate control over it. So imagine that we have this aircraft ticket, and it has a combination of data attributes like the seat number, flight number, whether drinks and food are included, which type of meal is included, everything that is stored on the blockchain. And then you have your wallet on the blockchain, and you have access to that blockchain record, and that's basically it. So you can do whatever blockchain allows you to do with that combination of records. So if this is so simple, so why there is a hype around such things like NFT? Let's take a look. So NFT essentially have those four properties that make them quite interesting for the business. First of all, the NFTs on the blockchain, they store a full history of ownership. So if we have this our flight ticket, we can trace it from the beginning when it was created by the company, and we can trace all the previous owners of the ticket and the price they paid in fungible tokens to change the ownership, or probably this ownership was changed for free when you were just giving it over or gifting. Also, when you move the non-fungible assets between the owners in the blockchain, you need to move the asset as a whole. So compared to the Bitcoin that can be split into smaller pieces called Satoshi, or in Near, we have one Near can be split into the Yoctos, the Yoctoneers. Then NFT you cannot move in a parts. So if you're moving all the attributes, you're moving all the attributes. So you cannot move the flight number, but don't move the seat number, right? So everything is indivisible. And also, as blockchain is not a trivial database where you can put pretty much all the data and the binary data, the textual data, images, music, and so on. Blockchain, in the blockchain, you need to be to be careful with the space you take there. So when you need to refer to other assets, then those assets typically are referred to some external storages. And for example, if you would like to store some image or video or sound, then it will be stored somewhere outside of the blockchain and just needs to be somehow clever linked to it. And that's what is called the metadata and external assets. And finally, because we say that NFTs have a very subjective value, then their real-time value, the current value, is often determined during the bidding process at auction. So they don't have any fixed price typically. However, this of course may vary. And once we start working with it with the end users, and we talk to different people and in the forums and the chats, and we figured out that users actually expect the three properties to be covered by the NFTs, and those are authenticity, liquidity, and people want tokens to be manageable. So basically, what does it mean, the authentic NFT? Authentic NFT means that there are no copies exist elsewhere. So imagine the same aircraft ticket. Obviously, you want to be sure that only you own it. And even if you arrive to the airport late, there is no other user who is using the same copy of your ticket who could bypass in front of you and take your seat, right? And obviously, people expect that NFT tokens were minted by verified creators. So if it's an that you really hold the aircraft ticket that is valid and real and not a kind of a fake copy. The same, people expect that NFTs should be liquid. So it's can be easily sold somewhere if you don't need it. If you cannot attend the flight, then you can easily sell it on some marketplace or pledge or whatever else. And obviously, if you own a lot of assets, a lot of NFT assets, people want to have some sort of the wallet where they can keep them and when they can browse them and yeah, have just an accountability of what they own, and even keep the control on the assets, even if the creator or the marketplace of the even probably the blockchain project that minted the asset goes out of business. Yeah, of course, with the airplane tickets, it's hard to imagine that if air company goes out of the business, you can still use the ticket, but with many other assets, it's still possible that they keep validity even even if the issuer is not anymore active. So those are three properties that people expect. And now let's see for the most obvious business cases that benefit from using the NFTs. So you might know that the artworks and collectibles is very widely discussed topic, and you might heard about myriads of marketplaces exist. So let's not touch this topic much. Second prominent use case for the NFTs is so-called access management. So here we are using the NFTs like a tokens, like passwords or the certificates to access something, be it flights or cinemas or shows, events, and so on. Another use case is supply chain tracking. As I mentioned, the blockchain keeps the record of all owners who changed the token, and this can be used for anti-counterfeiting purposes, like tracing the assets from the manufacturing till the consumer and even on the aftermarket to make a difference between genuine items and the copies. One prominent market will be the gaming. If you are playing games, you might know that if you have a car that you developed and upgraded in one game, that's currently hardly can be used outside of that particular game. And in the future, we can imagine that gaming assets can be easily transferable between games of the same publisher or even between the games of the different publishers. So you can actually take your sword out of the one game and import it to the hero into a completely other game and trade it on the market and so on. So just turn on your imagination how the NFTs can change the gaming industry, the esports industry. And finally, quite boring topic of the licenses and certifications, so that basically, thanks to the blockchain that can be cryptographically verified, NFTs can hold the value of the study points, education points that students earn at one university and then transfer to the another university as an NFT tokens, and they use as a proof of earning some education. So those are the most prominent NFT use cases. And here is the short image showing the NFT ecosystem as it is now. So it's the near view, so near blockchain, near protocol view on it. And I won't comment it much, just will say that in near, every business, you see them here on top. So business can run different smart contracts on his behalf. And one of the smart contracts should be a so-called NFT contract that works as a producer and a holder of all NFTs. And then when this NFT is issued, then it's referenced from all other marketplaces, lending platforms, and actually, so the NFT stays and at the NFT contract, and all others are referring to it. And the NFT contract itself is referring to some decentralized cloud storage if it needs to store some other assets. And basically then the money exchange, the owners, the money travel across the network, but the NFT itself doesn't travel much, but it's encapsulated within the NFT contract. So that has some advantages and disadvantages, and that's what we will discuss now in the next slides. But before we go there, I just would like to bring one example, and here I will a little bit deviate from the near protocol that we said, and the reason for that as of today I couldn't find a very good prominent example of the NFT token that was sold on the near protocol and that is worldwide famous. So that's why I took another example that you probably heard of. It's the Time magazine cover that were tokenized and sold for more than 100,000 K, 83 Ethers in March this year on another NFT marketplace called Super Rare. And here, so that's basically the anatomy of the NFT token. So just to show you that they are the architecture is quite similar between the different blockchains. And so this was the cover that was sold, and how actually it works, that actually what was sold to the people, to the person, or what was offered to the people and was sold is the, if there are technical people among us, that you can see the JSON structure here with the key value pairs, and that's basically the reference, and you can see that it's entirely stored off-chain, and inside the smart contract is placed only a link into this off-chain structure, and this off-chain structure holds the image, holds the description, and everything else. And here I put, if you're curious to explore it on your own, I won't spend time on it. You can visit this link, and you will end up on the Super Rare. You can visit this link. You can go here to the transactions. You will end up in the Ethereum Etherscan network browser. There you can find the smart contract. If you find the smart contract and you put into the smart contract the token ID of that particular NFT, you will get a link to the metadata stored externally in the IPFS decentralized network. And here you see the data stored elsewhere, and then you see the actual JPEG. So it's a trivial JPEG file that was high resolution JPEG file that was stored here. So that you can explore and play with it on your own. So now it's time to finalize my talk, and basically where we are now from the business perspective. So I took the Google Trends and mapped them with the Gartner hype cycle. And you see a pretty nice correlation here. So in the beginning of the year, we got this technology trigger that everyone started minting the NFTs. And we were somewhere on the positive hype when the interest over the NFT was growing rapidly. Then we reached now until May, we reached so-called a peak of inflated expectations, when a lot of people were hoping to either make an easy money on the NFTs, or they were exploring building and trying to apply the NFTs to different topics. But However, they were facing various pitfalls that we'll discuss now. And now I assume we're on the negative hype. So this means that interest is declining, but that's not a problem per se. So because what happens next, according to Gartner, it's kind of what we have seen with another technologies, that after the negative hype, we will follow the slope and enlightenment when people actually understand what NFTs are good for. So what is the real usage of this technology, where we can really benefit from it, and we will reach the plateau of productivity. So when the technology will be used just for its purpose and with the ultimate business and the user value gathered from it. So, but that we expect to reach probably by the end of this year or early next year in 2022. So let's be positive here. Yeah. So, and now the summary before I give the microphone over to Luis to look into the code. Just when you are dealing with the NFTs, be it on the Near protocol or being on any other prominent blockchain today, just think about those questions. Whether you're on the buyer side, on the seller side, on the marketplace owner side, or as a technology partner, think kind of how the particular blockchain implements the NFT concept. Like, is there to see a place like a wallet to see all your NFTs and the status? Do you understand clearly what is stored on chain, which attributes are stored on chain, and those are cryptographically proved, and what is stored off chain? Also, ask yourself what was done to ensure that NFT is really unique, that the same asset is not offered on different marketplaces or in other blockchains, or probably even off kind of in other websites that are not blockchain projects. And if you're storing something off chain, think how you're protecting those assets, because most probably you will face the most expensive 404 error ever if your offset off-chain assets be missing. Also, design your system the way that you can easily transfer the NFTs to another marketplaces. So there should be a way to standardize the NFTs and to move them freely, at least within the same blockchain, but probably even the cross blockchains. And obviously to make them affordable, to make them sellable for any cryptocurrency, or potentially even for the fiat money. And also you should ensure that you're not dealing with a scam, fraud, or money laundering, or not purchasing the assets that were stolen from real artists and sold by the people who are impersonating the real artists and the real creators. So all those questions are quite important to ask yourself when you're dealing with the NFTs. And some of them are already answered, some of them are yet to be answered, and some of them are answered differently on different blockchains. So we're not discussing now in details answers for that. And instead, I would like to now stop talking about the theory, and we covered it a lot. And that's the point when it's time to jump into the demystifying the coding part. And here I'm again welcoming Luis, who prepared some code for you. And don't worry, nothing will be too complicated. And if you would like to go into the really deep dive today later, will be another deep dive into the Near, and take this our show as a short intro into the development with Near. So Luis, please take over.
Yeah. Hello guys. Yeah, let me. Yes, I'm going to share the part of my slides. Yeah. So here we are. So Sahar already talked about the NFTs, and the idea is how we are going to build one. So let's try to see if we can come up with a proof of concept of an NFT project. So as Sahar mentioned, a non-fungible token is essentially a certification of ownership within a blockchain. That is, being a digital certificate, we need to ensure that each token is unique, and that each token is not interchangeable, meaning that two different tokens are not exchangeable to each other. To support this feature, we need smart contracts, which essentially are programs running within a blockchain that can create and fetch information. The state of the smart contract is stored publicly within the blockchain. Essentially, we want smart contracts, because they are event-driven, meaning that their code is executed only when needed. This implies that you only are going to pay for execution. They are serverless, meaning that there is no need to provision any servers, as they are provided by the blockchain infrastructure. And finally, they are decentralized, in the sense that it is not run only by a single node, but by a network of distributed nodes. So NEAR is a blockchain that allows us to execute smart contracts. We partnered with NEAR a couple of months ago to develop some NFT solution. Before diving into the development with an NFT contract, let's see an overview of the NEAR blockchain. NEAR is a proof of stake instead of proof of work sharded blockchain. Essentially, proof of stake is to have a skin in the game, meaning validators, as opposed to miner in proof of work blockchains, need to stake some native tokens. In the case of NEAR, is called NEAR, to be able to validate transactions. One of the biggest advantages of NEAR is the leverage of WebAssembly.
Luis, sorry to interrupt you, but we cannot see your screen.
Oh.
Could you share it, please?
I thought I was sharing. Sorry.
Thank you.
Yeah, sorry. Yeah, so yeah, WebAssembly. WebAssembly, or WASM, is a virtual machine that allows NEAR to execute smart contracts. WebAssembly has some features that make it suitable for the engine execution of a blockchain. It is platform independent, in the sense that it can be run in all major operating systems. Deterministic, without floating point operations. The compiler will generate WebAssembly code that operates on the same on each virtual machine. It is sandboxed, meaning WebAssembly is compiled into modules that provide additional security. WebAssembly modules can be compiled into small size files, making them ideal as it optimizes space in the blockchain. And it can be implemented reaching high performance since it's close to machine code. Moreover, since WebAssembly is a virtual machine, it defines an architecture, a set of instructions for the virtual machine. Each module is compiled into a binary that you can see that everything is not understandable, but actually this file can be interpreted as text using the WebAssembly text format. We mentioned that NEAR executes a smart contract compiled into WebAssembly, but how can we create them? So currently, NEAR supports two major languages to write smart contracts in. The first one is AssemblyScript. AssemblyScript is a dialect of TypeScript, but includes type annotations for WebAssembly types. Like in this example, I32, which is a signed 32-bit integer. So if you come from either JavaScript or TypeScript, AssemblyScript should be straightforward to start with. The other major language is Rust. Rust is a general purpose language that can be compiled to native code. And here we can see a small example of what Rust looks like. It's in spirit, syntactically is similar to C, but under the hood is completely different. So why do we want Rust? Essentially, Rust provides what is called zero-cost abstractions, meaning that there is no runtime overhead for language features that you don't use. Moreover, it provides performance. It's really fast and memory efficient. It is reliable, meaning that Rust has a really nice type system that allows you to prevent and eliminate bugs at compile time. And also you can be productive because it has great documentation, a friendly compiler, and also integrates a builder and a package manager tool. So let's see how to build an NFT contract for the NEAR blockchain using Rust. The code for this demo is going to be, it's already in this GitHub repo if you want to take a look. So let's get into it. So here we are going to create a new Rust project from scratch. We'll use Cargo, which is the Rust package management tool, to create our project. The init command tells Cargo to initialize the new project. And here we can see that we have only 2 files, and this is our entity project for our library. So the first thing that we're going to do is to set up some configurations, and the first thing we need to do is to tell Rust that we are going to that this is going to be a library. The dog test is essentially to avoid running the documentation test that Rust provides. So here we are omitting, and then we are going to add the NEAR SDK. The NEAR SDK is essentially what the NEAR community provides to build smart contracts. You can add as a dependency and allows you to compile and test smart contracts. Then here we are going to use the version, and then we are going to make some changes to the compilation options, so we can check like for overflows or compiler optimizations. Then we continue by setting up the first thing that we need to do when setting up a Rust smart contract is setting up the allocator for WebAssembly and then some imports. And here we can see that our main data for the smart contract is only a simple Rust structure. We need to provide some attributes like near bingen that tells Rust, the SDK, that this is going to be the main structure for our contract. Then we need to add some more attributes to be able to serialize and deserialize from the blockchain. So let's add some fields. Essentially, we want the NFT. We want to map for each token ID. We want to map to a token. So let's define those two types. The token ID for us can be a string, but also in your NFT can be maybe an integer or something else you want to be. And then we define our token structure. So in our token, we are going to set some attributes to serialize and deserialize. Serde is actually used to make to be able to serialize and deserialize from JSON when using it as a part of the public interface of the contract. And here, this is our main structure for the token. We can see that we have the token ID, the owner ID, which actually is just an alias for a string, and we have some metadata. Now, this metadata is actually suggested by the NEAR community. They develop several standards. One of these is how to make an NFT contract. And the idea of this standard is to be able to different contracts made by different developers to interact with each other. So then you can transfer, and then you can have marketplaces that can interact with any NFT contract. So we have, let's add the metadata, and as we were saying, we are going to put the fields that they are indicated by the standard. And here we can see there are some things like title, description, media. And as Zachar was mentioned before, in the last example, you can see that media and media hash, they are the links that they are going to provide off-chain. So if you actually want to, and this is actually the link that you need to provide. So yeah, we have these different fields, and then we are going at last we are going to add some more metadata for our contract. In this case, it's going to be the NFT metadata. The NFT metadata is essentially some additional information that we want to have for the whole contract. And let's see how it's going to be, what data can we have. This structure is also provided by the NFT standard. And here we can have things like the spec. Okay, and finally we have the tokens per owner, because what we want to do is we want to have a mapping to be more efficient from each account ID, which is the owner, to the set of tokens that he or she owns. So we are going to add now an import section in Rust. It's used to add code to a struct. And in this case, we are using default, which allows us to create a new instance of the contract. So what we want to do here is to return self, which is the NFT struct that we see before. And we want to essentially to create a new instance and return it. And this is going to be serialized in the blockchain. So for each field, we need to initialize with some default mapping. And here we can see that we are using the storage key. A storage key is what we need to do for each collection that we want to store in the blockchain. And finally, we are going to set the metadata with some dummy data for this demo. And you can see that in the spec, we can put the version, some name that we want for our NFT, and the symbol. And ideally, this is going to be shown in any marketplace or by anyone any user interface that want to use this NFT, right? So let's so here, and then we set all the things we don't care for now, but we can use an icon also if we want. Let's continue, and we are going to, so with this setup, let's compile, build the contract that we have so far. So we are going to make the target WebAssembly. We are going to compile for release, because essentially when you compile for release, you are going to make the contract smaller in size. And this is important when you want to optimize storage in the blockchain. So we are going to run it. Here is compiling, and we can see the output of this compilation is just the WebAssembly module. And this is what we are going to deploy in the next steps. So we are going to continue with the implementation of our contract. And we are going to make, to create a new method to return the metadata, the NFT metadata. So this is for the whole contract. Here self refers to the contract that is stored in the blockchain. Right, so here with this method, we just, every time that we are going to call it, we are going to return this method. Okay, now we are going to do the interesting part. We are going to actually mint the NFT. Minting means we are going to create something on chain. We are going to need the token ID on one side, and we are going to need the metadata. And we are going to do this in a couple of steps. The first one would be to just create an instance in memory within the WebAssembly virtual machine of of a new token. So we set the token ID, and we need to have the owner. Here, the owner is represented by predecessor account ID. This is what NIRS provides to retrieve the account that signed the transaction. So we are going to add the metadata, and here we just inserted in the map that we mentioned before. So we are creating the mapping between tokens and token ID and tokens. Then what we need to do, this chunk of code, essentially what we are doing is making the map between tokens, between the owner and the set of tokens. So here we want to say that for the predecessor account ID, we want to add the new token that he or she minted. So how are we going to make this, are going to retrieve this new, the new token that we just created? Well, we just use the NFT, create a new method, NFT token, and we are going to just return it. And we need the token ID, and if the token ID is not found in our map, we are going to return none, which is essentially the that there is no value for that token ID. Okay, so we have our contract ready. So we are going to now is the time that I need to log in, and here you can see the Explorer how it works. So we are going to log in using the CLI tool, essentially to make operations from the command line. In development, you don't need to do this. You can do all automatically, just for the demo purposes. Okay, so now we are logging with my address, which is Luis testnet, my account ID, and we are ready to deploy our contract. So the dev deploy command just is a subcommand that the near CLI provides to make deployment for development. We are going to take our module, the one that we just compiled before, and now it's deploying. And here we can see all the information that the transaction created, the account, the new account also created where this contract is hosted, and we can see the Explorer, in the Explorer, all the details about this new deployment. So we can see here again the new account, the transaction, and some more details about consumption in gas and also in token terms. So we have an NFT contract, a small one, and we already deployed it. So now it's time to, so this is what we are showing here is, this is a local file where the account name is stored. So we are going to use this information to just call a method in our contract. In this case, we can use something like let's call NFT metadata. So here we are retrieving the data that is stored on the blockchain that we use when we construct the contract. We are just retrieving it. So this is the way that you can actually use from interact with the smart contract from the command line. Also, you have an API to do it in the browser. So and now we want to do something more interesting. So let's create a token, and we do so by using NFT mint. And we set some arguments like the token ID and also the additional data, the metadata that we want to use, let's say some title and description. And this is going to store this data on chain. Right here we have the title. And again, there is a new transaction being created. It's being signed by my account, Luis.testnet. And we can view it in the Explorer, and we can see how everything is public because all the arguments are visible from the Explorer, right? So we created now a new NFT. So let's see how we are going to get it. And we can do so by calling the NFT token, the method that we created before, using the STEM ID, in this case, just 1, 2, 3. And here we just fetching the data from the contract. So essentially, this was like a really small, really short introduction to an NFT contract. We've seen Rust, Near, smart contracts, and also NFT. So we have this introduction. So if you want to, like, where do you want to go from here? Like start with the documentation on here, which is like, it's really good. They have its detail. You can start exploring. They have a lot of examples that you can explore, and also there are NFT examples where I took some inspiration for this demo. And finally, it's really nice if you can take a look at the GitHub, because they have all the code and everything that we just showed. So that would be it on my side. So yeah, thank you guys.
Thank you very much. Actually, we are running out of time. We have two questions, but I will kindly ask you to ask them offline. So thank you everyone for joining. Thank you, Sahar. Thank you, Luis. So thank you everyone. And this was the first talk of the last day. See you then. Bye-bye.
Thank you. Bye-bye.